All right, in this section, we're talking about arcs and chords and the relationship between the two of them. So really for this section, you just need to know 4 theorems and you can solve all the problems in this section based on those theorems. So let's take a look at our first one here, theorem number 1. So it says, in the same circle or in congruent circles, 2 minor arcs are congruent. So minor arcs would be like arc AD and arc BC. Okay, so 2 minor arcs are congruent if and only if their corresponding chords are congruent. So here would be a chord AD and chord BC. So if we're finishing this little statement here, it says, given that AD, which I could mark right here, is congruent to BC, then I can conclude this right here, that the measure of arc AD is going to be equal to the measure of arc BC. And that's all that one says. So let's go ahead and look at theorem number 2, which I finished for you already, so you can write that down. All right, so this one says, if a diameter of a circle, which we've got right here, here's a diameter. If a diameter of a circle is perpendicular to a chord, here's my chord, then the diameter bisects the chord and its arc. Okay, so if we have a diameter and we know there's a right angle, it's perpendicular, then we can also conclude that it's bisecting this chord right here. So we would say then AE is congruent to BE. You could also say that the arcs would be congruent as well. You could say arc AD and arc BD would be congruent. This one I think is pretty intuitive. If this one is not perpendicular, like if you don't have a right angle here, which I kind of sketched it out right here, same situation, but instead of it being perpendicular, it's kind of off like this. So no right angle, but I do have a diameter. So if it's not a right angle, you can see that it's not cutting this chord in half, right? It's not bisecting it. This part is shorter than this part, and obviously this arc right here is shorter than that one. So it only works if you have, boom, 90-degree angle. All right, let's look at theorem number 3. Okay, so theorem 3 says, if one chord of a circle is the perpendicular bisector of another, then the first chord is the diameter of the circle. Okay, this basically says the same thing that theorem 2 says, just in reverse. Like it says here, it's the converse of theorem 2. Okay, so let's read this out over here. It says, if AE, so boom, AE is equal to CE, let's mark those congruent, then what could you conclude? Well, then DB, it's saying, would have to be a diameter. It has to be going through the center of the circle if it's bisecting this chord. There's no other way that could happen. And I kind of drew that one out for you. For instance, put this one right here. So if it's not a diameter, right, if it's shifted up like that, it's obviously not bisecting these parts right here. So the only way that it's ever going to bisect those is if it goes right through the center, like this one, and it's bisecting it, and it has to be perpendicular. Okay, so we could say if AE equals CE, then DB must be a diameter. I'm gonna write that out. Boom. Okay, let's look at our last one, theorem number 4. Okay. All right, so theorem 4 says, in the same circle or in congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Okay, so let's look at just that much. So it says 2 chords, so it's obviously talking about A, B, and C, D. They are congruent if you can show that they are equidistant from the center point P. So if you can show the distance, in this case it would be EP, or PE, as they have over here, is equal to distance PF, then you can conclude for sure that AB and CD are congruent. So let's write that down. Then AB have to be congruent to CD. There you go. And then keep in mind, and this is important, they have in parentheses what it means by the distance between the center and the chord. Distance is always like the shortest distance between the center and this one. Like you can't just say, oh, that's the distance between them, or that's the distance. It has to be specifically the perpendicular line that you can draw. So this is going to be a right angle when we're talking about the distance right here. Same here. Distance from P to this chord would be the perpendicular line that you can draw. That would be the distance. All right. So those chords have to be congruent.